In problem number 5, we've got a pile of candies, and if we take those candies and we arrange them in rows of 4, we have 2 left over. If we arrange them in rows of 5, we have 3 left over, and if we arrange them in rows of 7, we have 5 left over. What is the smallest number of candies that the pile could contain? Well, let's see. Let's look at this. If we arrange them in rows of 4, we have 2 left over. So if we had either two less candies or 2 more candies, then we'd have a number that was evenly divisible by 4, right? If we arrange them in rows of 5, we have 3 left over. So if we had either 3 less or 2 more, we'd have a number that was evenly divisible by 5, right? And if we arrange them in rows of 7, then we have 5 left over. So if we either have 5 less or 2 more, then we would have a number that was evenly divisible by 7. So if you notice that in each case, if we had 2 more candies, in this case, if we had 2 more candies, we'd have a number evenly divisible by 4. We'd also have a number evenly divisible by 5 and by 7. So all we need is 2 more candies. So I'm going to define a variable here. Where did my pen go? Oh, there we go. I'm going to say n is equal to the number of candies, okay? Alright, and so I'm going to say n plus 2. Now, what do we know about n plus 2? We know that if we had 2 more candies, the number of candies would be evenly divisible by 4, 5, and 7. So I'm actually, instead of an equal sign, I'm going to say n plus 2 is divisible by 4 and 5 and 7. Okay? You see that? That's the key to this problem, is recognizing that if you just had 2 more, hey, we'd have a number that was divisible by 4, 5, and 7, right? Because we have 2 left over here, 2 more would give us 4. 3 left over here, 2 more would give us 5. We have 5 left over here, and 2 more would give us 7. So we know that n plus 2 is evenly divisible by 4, 5, and 7. So another way of saying a number that's finding a number that's divisible by 4, 5, and 7 is the least common multiple, right? So essentially n plus 2 is the least common multiple of 4, 5, and 7. Alright? So what's the least common multiple of 4, 5, and 7? Well, there's no common factors because this is 2 squared, right? And 5 is a prime and 7 is a prime, so there's no common factors. So all we really need to do is multiply these together, right? So this gives you 20, and times 7 is equal to 140. Alright? So that tells us that n plus 2 is equal to 140. But we're not looking for n plus 2, are we? We're looking for n. So n has to be equal to 138 candies. Oops, candies. Alright? So, that's our answer. That's the smallest number of candies. It's just the least common multiple of 4, 5, and 7 minus 2. Okay? So, there you go. It's not so bad. When you see these sorts of divisibility problems, or, yeah, these remainder problems, really, think in terms of, okay, how many more would I need? How, try to find something that's common between all of them that would give you something that's divisible, common factor or something, okay? So there you go.